For the last part of problem 15.5.46, so part E, we're asked to look at the residuals for this model. And so recall that we went through and determined the VIFs, and we did a stepwise regression to come up with the model, and we used only the GPA and hours independent variables. So we used XLStat to get this information, and finally we were asked to check the residuals to see if there's some constant variance with the residual plots. So by constant variance, we're referring to homoscedasticity, and we are looking for essentially just kind of a random pattern of the plotting of the residuals here. So this is an example of how that would potentially look. You'll see tons of examples online, and most of the time it's really hard to tell what you're looking at. But for heteroscedasticity, which is when we have a problem, you tend to see some sort of pattern develop within the residual plots, as you see here in this example. So this is a fairly good example of what a good residual plot would look like versus one where we have an issue. In more advanced statistics, there are some corrections for this issue. So whether it is a time series model or a cross-sectional model, more advanced applications, software applications have corrections for this as well. So for our purposes, we are looking to just build a residual plot for our independent variables that we're using in the model, which again are GPA and hours. And XLStat isn't really the best option for that. I prefer personally just to use the data analysis toolpack. So after running all the XLStat outputs, the regression, and determine that output, I just come right back into the data analysis toolpack and just run that same basic regression. It doesn't have to be a stepwise because we've already used the stepwise regression to determine our model. And we know that our model is going to have the same dependent variable, which is score. And for the independent variables, we're just going to have the first two, GPA and hours. So we can duplicate our model coefficients and our linear regression equation in the data analysis toolpack. So for output, I'm going to go ahead and place that down here. And then you'll see that we have the residuals box checked and the residual plots checked as well. So normal probability plots is not great in the data analysis toolpack just because it's plotting a dependent variable as opposed to the independent variables, so not as useful. But let's click OK here. And so here are our residual statistics. Remember, the residuals are just the difference between the actual observations and the predicted scores. So the actual scores versus the predicted scores, the difference is the residuals. And we have our same coefficients here as we determined in XLStat. So again, we're just running the same model but using the variables that were determined through the stepwise regression in our initial run at it. Okay. And then what we're interested in is the plot for the hours and the plot for the GPA. So as you can see here, not too bad. You can't say that these are perfect or really nice looking residual plots. Again, like I said, a lot of times it'd be very difficult to tell if there is an issue with more advanced statistics. You probably just run the heteroscedasticity correction in the software most of the time anyway, just because this can be hard to tell with the residuals if there is a problem. But these don't look too bad, so in this case we just consider that there is a constant variance and that assumption is met for this particular data sample.